Good morning. This is lesson 2 in trigonometry on using trigonometry to find an angle. How do we use trigonometry to find an angle in a right triangle? The do now question is just a review of what we did already. So I'm going to go down to the lesson. When we're still going to want to keep fresh in our minds that little reminder on how to remember which function is which ratio, and that is SOHCAHTOA. So it might be helpful for you to write that down and keep it in your on your sheet. In this problem, we're given right triangle ABC. Leg BC is 15 and leg AC is 20. And we're asked to find angle A to the nearest degree. We're not asked to find the length of AB, although we could find it using the Pythagorean theorem. Remember, one of the ways to know we have a trig question is because we have an interaction between angles and sides of a right triangle. So the question you want to ask yourself is, well, which function would I use to find x given the information that I have? Since BC is opposite the angle x and AC is adjacent to the angle x, when I think about SOHCAHTOA, I'm going to use tangent to find x, because the tangent of the angle is the ratio between the opposite side and the adjacent side. You know how to do that from when you were looking for missing side lengths. The only thing that's different here is we're looking for the angle. So remember when I told you that your calculator has stored in it all of the ratios for each of the angle measurements for sine, cosine, and tangent. It's just storing information for you. It's still storing those ratios. Those ratios, remember, because of similar triangles, are all the same ratio for each angle. So we have to tell the calculator now, we don't want you to give us a side, we want you to give us an angle. And there has to be a communication between you and your calculator to say, I don't want you to give me a ratio for a side, I want you to use those ratios and take the ratio I'm giving you and tell me what angle it applies to. You're kind of asking your calculator to work backwards at this point. So this is the notation to do that. The tangent comes over to the other side, and you say the angle is equal to the inverse tangent of 15 over 20. Don't let this confuse you. It's really just a notation. This notation is a signal for you to tell your calculator, I'm using trigonometry, but I'm not looking for a side, I'm looking for an angle. That's the notation that you use for that. Use when looking for an angle. I'm going to go to my calculator now and show you how to do this. So when you go to the input and go to functions, right underneath your sine, cosine, tangent, you might not have even noticed that it was there before today, is sine inverse, cosine inverse, and tangent inverse. So you're going to press tangent inverse for this question, and then 2 parentheses will open up, and you're going to put in the ratio for this question. So go back to numbers, 15 divided by 20. And the calculator got your message. We're not looking for a side here. Now we're looking for the angle for that ratio. And so it gives me 36.869897 blah, 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 blah degrees. We want that to the nearest degree. So we come up with angle A is approximately 36.86 to the nearest degree rounds to, I know you know this, 37 degrees. Now, the only thing that will be different about doing the problems in this lesson is you'll have to make the decision at the beginning of the problem, which function am I going to use? The same decision you made when you were looking for a side. And then when you go to use your calculator, you have to tell the calculator, I'm not looking for a side, I'm looking for an angle by using the inverse. Please email me any questions you may have and work on the problems on this sheet today. Okay, today's Monday. Work on the problems on this sheet, and then tomorrow I'll post the answer key and we'll do a little bit more practice. Have a great day. Bye.